Today I'll be showing you guys how I created this maze right here. It allows you to create basically a modular maze that has a definite solution that you can go from start to finish. And as you can see, it is completely modular. And not only that, if I go ahead and inject, you could see it is actually partitioned. So here you can see it is actually just loading up the parts next to the player. If I move my camera away, it is just loading that area. So it is quite performant as well. So let me show you how to create a maze of any size from your starting location to your end position with a guaranteed solution and a way of incorporating level instances with hierarchical runtime generation in PCG all together to create this. And while I am doing it to create a maze, you can use this potentially for many other use cases, as you'll see. I should note the previous Sunday's video was a video on hierarchical generation at runtime and things I wish I knew before I got started. I would highly recommend watching it because I'm going to go a little bit faster over the things I covered in that video, because there's just a lot to go through. But I'll make sure to leave it in the description, and you'll also see it here in the card. So definitely check out that video so you get familiar with HiGen, and so some of the stuff that I'm going to do here will make a lot more sense if you haven't seen it already. But with that out of the way, let's get right into it. And I'll start with this template of a maze, effectively, because this is how I've created my maze modules. I don't generate the entire maze through a complex network. Instead, I make it through modules of level instances. The reason I'm doing this is kind of twofold. One, it is significantly easier. Two, I can control sections of the maze to be however I want, which means if I want different sections of a maze to be a certain type, a certain look, maybe I want dead ends to look a certain way and have like pots and pans nearby for whatever reason, and then the walls to be covered in ivy, whatever it is, I can just set up the level instance to have the meshes where I want, in the way I want them, and it will assemble it all together. And then in the actual generation of the maze, I can customize whether it appears, doesn't appear, where it appears, etc. So this is the template. But you might be thinking, okay, well, this seems like a 5x5 grid, but how do I create a cool design for it? Don't worry, I got you covered with this website, codebox.net, and I'll leave that, of course, in the description below. You could specify here, you're going to want to generate a 5x5. It doesn't matter what kind of exits you choose because we're going to be putting them wherever they fit. And from here, you can just specify a new maze. You get generations of a new maze every single time. So you can now figure out, okay, I'm happy with this kind of layout. I'll put a door here, 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 and here, maybe all four sides. And then you can basically use this. And the way you'd use it is you just go in here and you remove the walls that you don't need. And in the end, you're left with something like this, where I just colored the floor a different color. And here's our design. And let's say I'm happy with this. These are made up of individual wall segments. You can absolutely set it up to be one large wall. You don't need to make the segments this small. The only things to note here are you want to make sure that the actual doorways are exactly in the center. So that way, if it rotates, it lines up. And you want these outer wall pieces to be half of the size of the inner wall pieces. So that way, when they touch another module, it looks like it's a full regular wall piece. Now, in my case, I have colored the floor so you can tell it's a new room just for the tutorial. So it's easier to tell, oh yeah, this is going to a new room. Or if you're using something maybe like a landscape, you can just bypass the floors entirely and just have it kind of embedded into the ground. Whatever you'd like, you have full control here. One other note about the method we're going to be using for the level instances, it is using the default materials assigned to the geometry. So if you've overwritten the material inside of the level instance, it will not use that, it will use the default. You can of course overwrite it however you'd like inside the PCG graph if you would like to, but just know that by default, it will use the one that's assigned to the static mesh, which is why in my case here, you can see I have 5 different floors here with all a different material so we can really visualize them. I'm also using a box that has the pivot point in the corner, but that's just for convenience. It is not absolutely required. The only other note is this one has 3 exits / entrances, and the only other alternative is 4. You can make versions with 2, that's completely fine, but just know the fewer 4-way versions there are, the more dead ends there are. And if you're fine with having more dead ends, use either more 3-ways or more 2-ways. But to actually make use of this, all we need to do is select all of the pieces that are actually part of this. So in my case, it's all of this. And all you need to do is go right click, go to level, create a level instance. We're not going to do external actors. We're going to do center minimum Z, and we're going to hit OK. And we're going to save this. In my case, I already have this one, so I'm just going to call it test level and hit save. And what this is going to do is it's going to lock it in as a level instance. So if I go ahead and delete this, I can drag out the test level right here as much as I want. So you know it's working correctly. If you take a look, I have a template and a template 1. Why is that? Because if I reload the template level, it has the level instance. It overwrites the file where it came from. So that's why I have a template 1, which is a copy of the original, as you can see right here. So now I can get rid of the original actual level and replace it. You can, of course, also just overwrite it through a save as, whatever is faster for you. I find just deleting, duplicating, and removing the last little number is quite quick. But just know that when you do create the level instance, it will overwrite your original level, so make a backup of it so you have a template. Now there's one step we have to still do, which is to prep the level instance for PCG. Thankfully, that is quite simple to do. If this is our level instance, all I need to do is right-click, go to Asset Actions, and all the way at the bottom here, create PCG assets from levels. If you only have one selected, you'll get an option to save it wherever you'd like. In this case, I'll put it in the same location. I'll just hit save, and you'll see we get a PCG data asset. If you have multiple selected, you could do them all at once. It will just save them all in the actual same location as you had the files, so it's a little convenient to do them all in one go. But this is the file we really need, along with the level instance. In my case, I've gone ahead and generated 5 different levels, all with their own PCG data assets, as you see here. So there are 5 different layouts, and based on the name here, you can see I have 3 4-ways and 2 3-ways. That's kind of the basic breakdown of how to set up level instances and convert them to something we're going to be using in PCG. But now that we have this, we can actually get started with setting up PCG. And of course, to do that, make sure you have PCG enabled by going to Edit Plugins, searching up PCG, and turning on the Procedural Content Generation Framework. And of course, restart your engine if needed. To get started, we'll grab ourselves a PCG graph under PCG, PCG graph. We'll use an empty graph, and it's going to be PCG_Maze. And we'll go ahead and drag it out into the world. And we'll right away set up the high gen partitioning and everything along those lines. So in our actual PCG graph, I'm going to open the PCG component, open settings, change it from generate unload to generate at runtime, and turn on is partitioned. And on our PCG world actor, I'm going to change serialization mode to always serialize, and treat editor viewport as generation source will be enabled. Also go ahead and scale this quite a bit higher to something like this to cover a larger area so we actually really get to see a larger maze. And now let's go ahead and open it and get started. Now in the PCG graph with nothing selected, we want to turn on use hierarchical generation, and we'll change the default grid size to unbounded. We will need this for some of the things later on, so we'll do unbounded and then set it up how we need. The first thing we need to do is actually create a grid. So I'm going to right click, grab ourselves a create points grid, and here we're just going to set it up to be something like 50,000 extents in X and Y, and the cell size will be 5,000. Now why is that cell size 5,000? Because in my case, that is the size of each module. It is set up as a 5x5 with each wall segment being 1,000 units. So if every segment is 5,000 units, I'm making the cell size 5,000 by 5,000. Of course, adjust it to your liking of whatever module size you're using. That will be the grid size for you. From here, I'm just going to grab ourselves a named reroute declaration node. I'm going to press F2 to rename it to just call it pre-partition grid. So if we ever need to do something before this node, let's say offsetting it or something else, we always have a way of grabbing it somewhere else later on. This is the original points as they were. But do not forget, we do want to change some other things on the create points grid, namely the coordinate space. We want to change it to local component. We also want to turn on call points outside of the volume. So that way we're not generating the entire points grid. We're only generating what's inside of the bounds. So if I press D on the create points grid, you can see all of the points are within the bounds. And if I scale it in a little bit smaller, you can see it has become smaller, even though it's 200 size. And if we go back to 500, you can see it just retains it within the bounds. It's perfect for us. If for whatever reason you do not see your points when you press D and then select it in the bottom left corner, sometimes it helps to press A to get the point information and then turn it off. And then it seems like the debug comes back. Small bug, but it is still in beta. Also, when debugging, you will see this UB. This is unbounded, and that's the partition size that we're using. So from here, we can go ahead and set our own partition size now. I'll use change grid size, and I'll make it something quite small, like 3200. You can of course go 6400 to load it a little bit higher. 3200 I find works pretty well. Again, based on the size of your module, you might want to go higher or lower. And then from the change grid size, we'll use a simple intersection node to only load the parts that we need, with the grid cell volume going into source 1. So from here, I can already drag out and search for a debug node so we can see what's going on. And if I go ahead and fly in, you will see there's our points, and there's them moving as we kind of move around. You can see it is kind of a 3x3 area based off of the center point, which is why this number works really well for me. If I was to change the grid size to 6400, you can see it loads considerably more area, which in my case, I do not need to load that much. We have walls everywhere to block the view of the maze. So I'll go back to 3200 and remove the debug. From here, I want to rotate all of the actual modules by 90-degree increments. So that way they're kind of rotated randomly, but they still work in a grid perfectly. Thankfully, that's really easy. To achieve that, all we need to do is create a random integer and multiply it by 90, and we'll get an increment of 90 degrees. So to do that, from the intersection, drag out and search for attribute noise. Now you'll see it throws an error. For whatever reason, it does not create a conversion node here. And I think mostly it's because it's a wildcard input technically here, and it does not like spatial data. So all we need to do is drag out of out and search for 2point. You'll see here under spatial 2point, you want to grab that. It will convert the spatial data to a point data, and then we can use attribute noise. So let's set it up. Our input source will be just point density, just because it's a single value. It doesn't need to be density, but just a simple, easy solution. Our output target, I will just call random rotation, and I will set it to be randomly between 0 and 3. 0, of course, is 0 and effectively 360, and 3 is 270 degrees, because if we go to 4, we will effectively create 360 degrees, which 0 takes care of, so there's no reason for that. Keep in mind, though, this does return a float. It is not an integer. So now what we need to do is drag out and search for toAttribute, and near the bottom here, you'll see point to attribute set. Now to make it easier for me to show you guys the values, I'm gonna select my PCG Maze, and in the settings, I'm gonna turn off is partitioned for the time being. So that way in here, I can select the node and press A with the PCG Maze selected, and you'll see here is the random rotation, and here's our float. During this process, it's just easier to work with it, not partitions, just to see the values. You can, of course, select the specific partition. You'll also get the values of the specific partition, whatever you find easier in this case. So now we have this. We need to round this number. Round basically takes a float and puts it to the nearest integer. So now you can see 0, 3, 2, there's ones. It is all randomized between 0 and 3. Perfect. And as I mentioned from here, just go ahead and multiply it by 90. So we get a random value between 0 and 360 degrees, at the highest being 270 because 0 is effectively 360. So now that we have this value, we need to set it. So using this point information, we'll drag out and search for set attribute. This attribute math operation set is all we need. And this out is going to go to inB. And in this set node, input source 1 will be a point rotation. And you want to specify rotation dot yaw. Careful not to put it in rotation.z, it's specifically rotation.yaw, like roll, pitch, and yaw for rotation. We can go ahead and use last for the input here. It is the only point information we have, and it is the last one being used. So keeping it on last on set is just fine. But now, if I press A on the set node, we can take a look and see that the rotation.yaw here has been now rotated randomly in 90-degree increments. So that's perfect. At this point, we want to go ahead and assign the level instances we created, or rather the PCG data assets, to these points. We want to assign a random one to each one. So first we need to make use of an array to actually select which points do we want generating here. If we go to the graph parameters, we can add a new parameter. Now the parameter type is going to be of type PCG data asset, this one right here, and you want an object reference. Right click on the point here to change it to an array because we want to have multiple. And I'll also rename it to maze modules. From here, I can go ahead and click the plus sign and add ourselves some of these. And you'll see in the drop down, you will have your options here. So I'll go ahead, add my options. I'll add everything except this last one, which I'll use for the main path so we can really see which one is the main path later. With this in, I can go ahead and grab it and drag it out here. And how do we make use of it? With a simple match and set attributes. All we need to do is take this maze modules and plug it in. You can of course combine it with many tutorials that I've shown in the past, like the data assets one, to really customize this to your liking. From here, we want to sample the actual information of these level instances. and copy them to the points randomly. To do that, we'll just drag out and grab ourselves a attribute partition, and we want to partition these points. In the partition settings, we want to partition them based off this maze modules. So I'll go ahead, instead of at last, we'll type in maze modules. If you typed it in exactly, it will give you no errors. And now we will need to loop on these points. Let's go ahead and create the PCG graph to loop on. I'll right click, grab ourselves a PCG graph. Again, it's going to be an empty graph of type PCG loop copy li for level instance. Then I'll go ahead and take it, drag it over, and select create a loop node. After that, I can double click on it to open it up. Inside this loop, for the input, I set the first input to be a loop of a type point that is required, and the second one to be an attribute set that is set to also required, that is normal, and I named it attribute. The output I just changed to allow types point and the pin status normal. So now we can go ahead and make use of this. From the input points, I'll drag out and search for get attribute from point index. This will allow us to get the attribute that we just set for the actual level instances. Now, because I don't want this hard-coded, I set up this attribute input that is going to go into our input source. So that way we can plug in something different, because we will need this in two different locations, so it's easier to just use the one loop that we can customize. But now that we have this, all we need to do is right-click and search for load PCG data asset. Now by default, this out here is showing a spatial data. So what I'm going to do is in the detail panel here, I'm going to change this asset to be one of these options. And as soon as I do that, you'll see we get root and points. But I want to still use what I have here from it. And so I will plug in the attribute into asset. If I was to undo this and I kept it as the spatial data, you will see that if I plug in the attribute now into asset, it maintains spatial data, which is why first I go ahead and select any one of these in the asset, and then I can go ahead and overwrite it with whatever it is, maintaining this root and points. I'm not sure why this is, but this is a simple workaround. But now that we have these points, we can go ahead and copy them onto the original ones. So from this in, just drag out, search for copy points. Instead of into source, this is actually the target, and the points from this load PCG data asset are the source. So I'll put it above here so you can really see that it's going from above into source. And the output of copy points just goes out, just like that. So now back to our main PCG maze graph, we can plug this out into the endpoints, and we need to add the attribute here. If I right-click and search for constant, we'll get a few different variables here. I'll go ahead and grab myself a new string constant, and for the string value, I'll just call this maze modules, which is the same name we called it right here, and that's going to go into the attribute. At this point, we can go already and drag out and search for a static mesh spawner. The mesh selector type is going to be by attribute, and the attribute name here is going to be mesh, because from this loop, we got all of the information of the meshes. If I go ahead and scroll down here, you could see there's our mesh. It is using my corner pivot here. If I continue scrolling down, you will see we'll get the floors. There's our floor Bs. So it is called mesh, which is why we're using mesh as the attribute name here. And if I take a look, there's our full maze. Start to finish, all of the walls here line up. The only reason we know this is a border is because we gave the floors different materials for each module, but there's our full maze. Now, of course, I have partitioning turned off, so all you need to do is reselect it, and turn on is partitioned. And now, if I zoom in, you can see it is working as intended. And if I go ahead and select our player start and just move it, let's say, over here, so it's not in the middle of a wall, and then I hit play, you will see that there we go. I can just go around, but the walls are kind of not really there. In fact, if I keep running, I will eventually just fall through the ground because it's actually using the floor tile instead of the walls here. And there it is. I am falling through the floor. So how can we fix this really easily? Well, in our static mesh spawner, I'm going to open up template descriptor. And this is basically the default settings of your static mesh. And you'll see down here, collision presets, no collision. Instead of that, I'm going to set it to block all. So whatever it's spawning is going to by default now have block all. You could absolutely still have attributes that override these values, but these are kind of the default ones. Here you could set different aspects of it, cast shadows, not cast shadows, etc. But this is what it's going to use if you don't override it with an attribute. So now if I go ahead and hit play, you will see that I can no longer run into and through the walls, which means I can now run around absolutely anywhere and check out this entire maze from start to finish. But the problem here now is I am not guaranteed a solution. And that's kind of important. I want to make sure I am guaranteed at least one solution to this maze. And the way we can guarantee a solution is by making sure that the main path is one that always has four-way movement. Now, other areas can also have four-way movement. If the main path is always four-way, that means no matter how it has rotated, it will always guarantee a path from the start to the end. So what we're going to do is basically have a start and an end. Now, before I do that though, one thing you might notice on this version is, well, we have a lot of holes here because a lot of these are either 4-directional or 3-directional where we have one side only filled in. And we kind of want a full wall all around this place. We don't want these holes. So first we're going to close up these holes and make sure that we can place the start and end at a specific location and keep those holes. And then we can go ahead and create the full main path. I'm going to just select all of this and comment it. This is going to be our main maze. Down below, I will set up the actual border wall. Now, in our case, I want to use the same create points grid, but we already have this pre-partition grid, so we'll use that. Now, right-click, search for pre-partition grid, and now we want to basically set up the exterior walls. This effectively will be just like the building series. I'm going to offset the points up, down, left, and right, and effectively wherever they overlap, that means they're on the inside. And if they don't overlap, it is the outside. So from here, I'm going to grab ourselves a transform points node. And for this first one, I'm going to open it and drag out from offset min and grab ourselves a new vector constant. This one all the way in the bottom. And then I'll plug it into offset min and offset max and close it up. We're going to do that because we need this a few more times. So this just saves me the trouble of creating a new constant for each of these. And I will plug in the pre-partition grid into all four. On these transform points, we want to adjust also the rotation, which is very important. The first one is going to be rotated -90 degrees in the z-axis. The second one is 90 in the z-axis. The third one stays the same, but the fourth one is rotated 180 degrees in z. So effectively, once we push out each point, we want to make sure that they're facing outwards from the center. Now for these constants, we're going to offset them by half of the size of the grid. So that way, when both the points are offset, it will potentially overlap. And if it overlaps, we're going to remove those points. So for the first point, we're going to offset it by 2500 in X. The second one is -2500 in X. Third one is positive 2500 in Y. And the final one is -2500 in Y. If your grid is bigger or smaller, you can adjust accordingly. Just make sure to divide by 2. After this, we just need to grab ourselves a few difference nodes. So I'll search for difference and I'll duplicate it 3 times for each of these outputs. The outs are all going to go into the source, just straight through, just like so. And then it's going to cross for the differences. So the first one goes into the second one. The second one goes into the first one. And same thing for the bottom 2. Third one goes to the fourth, and fourth goes into the third for differences. At this point, I can go ahead and drag out and search for a merge points node and plug the spatial outs into this conversion node for all of them. At this point, if I go ahead and debug the points and change the extent to absolute and maybe change the scale to like 10, we can see here are all the points all around inside where the entrances are. So that's fantastic. It is working pretty much exactly how we want, right at the border. I've gone ahead and turned off the partition again, which is why I'm seeing the entire thing. If you still have the partitioning turned on, you will just see the one section. So just keep that in mind. From here, we need to change the points grid, which is the same thing we did here. So I'll go ahead and select the same setup here and duplicate it over and plug the merge points right through. I could hard code the mesh that we're going to use, but I'm not going to. So instead, I'm going to drag out and search for add attribute. We want the parameter version for add attribute. And again, same as before, it doesn't do the conversion. So I'm going to detach and search for 2-point and grab ourselves a 2-point node and plug that into the add attribute. And what we want to do is add a mesh here. So back in our graph parameters, we'll add a new variable. I'm going to just rename this to wall mesh. And I'm going to change the type to a static mesh object reference. And I'm going to use the same box corner pivot that I used to create the walls. Then I can go ahead and just drag it out, plug it into attributes. And in the add attribute node, we'll change the output target to be mesh, just like the other nodes. So now if I go ahead and use a static mesh spawner, just like I did before, change it to by attribute with the attribute name mesh, you will see there's our point, but it's quite small and doesn't quite fit for this actual hole. So what I'm going to do is add ourselves a transform points here right before the end. You could do it earlier as well. We'll go ahead and just do it here. I'm going to uncheck uniform scale and scale it in X and Z by 10, which is the scale that I use for my walls. But you can see they're a bit offset, so we need to adjust that as well. So we need to adjust them in X and in Y. All I'm going to do is offset them by -500 on X for minimum and maximum. And I want to modify it by the full thickness, which is -100. And now if we fly around, you could see across the entire thing on every side, there's a wall that looks very, very flush. So perfect. We now have an enclosed maze. And if I go ahead and turn its partition back on and kind of fly down, when we're a little bit further away, you can see it generating the wall there, and then it generates the rest. So fantastic. It just seems like it's working exactly how we want. So now I'll go ahead and just select all this and comment it to be the exterior wall fillers. It's fantastic. We have the main maze and the exterior wall fillers. So now, as I mentioned, we need to get a way of getting from the beginning to the end, wherever we'd like, and make sure it's guaranteed. As you can see, I've extended the entire ground, and I've actually put the player spawn right here. So when we start, we'll be facing this wall here. This is going to be our entrance. I'm going to use the simple way of creating the entrance, which is using a create trigger box. We'll go ahead and create one here. I'm going to change the box extents from 40 to 400 in every single direction, which will make it easier to select the area. And now we can make a hole in our walls. So over here in our wall fillers, we go ahead and just move the static mesh spawner over. And from the transform points, we drag out, grab ourselves a difference node, and then right click and search for get actor data. We want a regular get actor data. So that way we can do actor filter all world actors. Instead of by tag, we do by class and of a type trigger box, just like that. And we want to make sure select multiple is turned on. And then we want to change the mode here for the data to get single point and turn on merge simple data. If you want multiple entrances, this will still work, but I'm going to be using the same 2 points for the entrance and exit. So you might want to do it by tag instead. So you can specify where's the start and end versus where is just an extra hall or maybe something else you want to put in your maze. So this is going to go into the differences. And on this difference node, we want to change it from minimum to binary and then plug that into the static mesh spawner. As you'll see, we now have a hole here. So that's great. But if I kind of zoom out, oh, we have a few more holes. Why do we have holes all the way out here? That's because we've been modifying the scale of the points from the grid that we originally generated, which were quite large. So if I press D on this transform points, you'll see our actual points, as you can see, are quite large, which is why it's grabbing a lot more than it needs to. So we need to make sure that the bounds here are the correct size. Thankfully, there's a note for that in the new versions. So we can put it either before or after transform points, it doesn't matter. But if I drag out of transform points and search for bound, one of them is bounds from mesh, which is what we want to use. And the mesh we're going to be using is, of course, the wall mesh right here. So we'll go ahead and plug that in and then plug that into the difference node. So now if I debug the bounds from mesh, you can see it is just right there. So perfect. We can now remove just the one wall piece at the entrance locations. Take this and put it inside of the main maze section as well. And you're wondering why that is, and I'll show you why in a second. Again, this will be probably more useful if you use the tag method, but if you put it here, you can now cut out any wall, not just the actual specific exterior ones in the centers. And if I wanted to, I could cut out an entire section of maze like this. If you wanted to, you could cut out sections of your maze and put something there and reconnect the paths however you'd like. You have the control of doing that. It also gives you the option of potentially putting the entrance not quite in a middle spot if you'd like, but in my case, I'll go ahead and just put it right there. That seems like a good location. And now we want to do the same thing for the other side though. So we'll go ahead and take it and hold Alt and just move it all the way to the other side. And we could say this is now our exit. Now, while I am putting these in manual locations, you could automate this. You have full control over this. Don't feel like you have to have a specific start and end point. But now that we have these, we need to create the main path and then make sure that it always works. So down below, I'm going to get started with this. Just like before, I'm going to grab our pre-partition grid, and I'm also going to get this get actor data node because I want our trigger box information. From here, we know we have 2 trigger boxes, so I can just drag out and search for random choice, and I'm going to keep it on default, which is going to take a fixed mode, fixed number, 1. So that means one of these is chosen and one of them is discarded, which is very convenient. So from the pre-partition grid, we can now use these 2 points for the pathfinding. But before I do that, I want to just add a randomness to it. So I'm going to drag out from the pre-partition grid and search for attribute noise. And just like before, the input source will be point density and the output source will just be random. And I'll have the random between 0 and 10. And now using this new attribute noise that we have, I can drag out and search for pathfinding, and we can set these up. Now in our pathfinding node, I'm going to have the start and the goal as inputs. I'm going to plug the chosen into the start and then discard it into the goal. I'm also going to change the cost function mode to either fitness score or cost multiplier. I haven't seen too much of a difference here. And the cost attribute will be the attribute we just added here, which is random. I'm going to turn off accept partial path. I'm going to keep it output as spline and change the type to linear. Now the final thing you want to change here, which is around at the very beginning, is the search distance. Again, it is the distance of your modules. In my case, modules are 5,000, so the search distance will be 5,000. Now you might be wondering, why do I output to spline instead of outputting to points? For some reason, when I did this with a spline that I then resampled, I found much better results than when I just did the points themselves. So that's why I'm doing it through a spline and then converting to points. In my case, I'll just keep this pathfinding as a spline and then use a spline sampler, and we're going to keep it on subdivisions, but we're going to change subdivision segments 0. If I go ahead and just debug this spline sampler and then change the scale mode to absolute and make it something like 10, you will see that over here we have our points, and it starts with the first one at an angle where the original one was, and the rest of them are actually in the correct location, and it goes all the way through, and again it ends with the end point. And I don't want this point or the one on the other side. I want to get rid of these. To filter out the first and last points, we're going to drag out and search for a filter range and grab ourselves a point filter range here. Now, the target attribute we're going to want to filter by is the index. We'll go ahead and select index for a target attribute. Now, the minimum threshold, we want to use a constant number. So we're going to use constant threshold, turn that on. And now in the attribute types, we're going to check that it is 1 or index 1 or higher. In this case, it is inclusive, so it is equal to or greater than 1. If you turn off exclusive, just set it to 0 and it'll be greater than 0. On the max threshold, we want to customize this a little bit. So first we need to know what is the amount of points we actually have. So from the spline sampler, I'm going to drag out and search for get point count. We're going to use this. If I press A here, you can see number of entries, 38. But don't forget that the number of points is different than the index. The index starts at 0, the number of points starts at 1. So we just subtract 1 from the number of points to get the index. So from here, I'm going to just use a subtract node, subtract 1, and that is going to go into our filter max. That's throwing out a warning because we haven't finished here, because it is still set to threshold attribute density. We want to set it to what we saw here, which is num entries. So I'm going to change this threshold attribute to num entries, and I'm going to turn off exclusive because we've effectively gone the last index. And I don't want to include the last index, which is why I'm turning off exclusive. And now from the inside filter, if I go ahead and debug this with a debug node set to absolute of a scale of 10, you will see that we now no longer grab the first point and we do no longer grab the last point. So that's great. So we got this filtered out. At this point, we have the main path, but we want to make sure that we can cut out the main path from the actual rest of the maze. So what we want to do is make those points that we just created for the debug to be the size of a room, basically. Actually, just under it. So dragging out the inside filter, I'm going to search for bounds modifier. And on this bounds modifier, instead of scale, I'm going to change the mode to set. The size I'm going to make it is negative 2450 on the X, Y, and Z to 2450 on the X, Y, and Z. So now if I debug this bounds modifier, you'll see it is now pretty much right on the inside of all of these rooms, which is great because now we can use it to cut out the main path here. So dragging out the bounds modifier, I'll add a new named reroute declaration node, and I'll rename this to main path. And as you might have guessed, in this main maze section, just right click, search for main path. We plug that into the differences here. And as you'll see, we have all our original sections here, but minus that middle area. So we technically already have a nice path from one to the other. And by the way, this is the solution. You can make this solution more or less complicated as you'd like. You can add more points to Pathfind 2. This is just the simple version. You can also make it so it doesn't go from the edge to the edge. You can also go to the middle point. You have a lot of customization here. But at this point, from this main path, we kind of need to do the same thing we did over here on the main maze. So I'm actually going to take all of this and I'm going to duplicate this down below. I'm going to plug in the main path into the change grid size here. We want to make a few changes, starting with the fact that we want to get rid of this difference node of the main path, because otherwise it's cutting out itself, and we don't want that. The other thing I want to do is change the actual modules that we're spawning. So in our graph parameters, I'll go ahead and add a new variable. It's going to be the same as the maze modules. So it's going to be a PCG data asset. And I'll go ahead and select as an object reference. Right click, convert it to an array. And I'll rename this to main path modules. And I'll add a new module here, and we'll set it up to the one I did not use. You can add more here, and we'll just pick the main path from all of this. My recommendation is just that you select 4-way main path. So that way it guarantees that the path is solvable, and the rest is whatever it is. So here, instead of maze modules, I'm going to right click and search for main path modules. And that's going to be our new match and set attribute. Now it is going to complain about this partition because we have set it to maze modules. So this needs to be changed to main path modules, which again makes this upset. So it needs to be changed to a different name. So this one also then needs to be changed to main path modules. And now all of these are all main path modules. So it is quite happy. And if we take a look, you could see that there's our new path. We have a rainbow road now going along the entire path. Might be a little bit difficult to see, but if I turn off the rest of it, there's our path. It is rotating as it does and goes all the way from one end to the other, guaranteeing a solution. And you might have noticed we had one that was angled at the very end, and you can see it is still angled here. Now, we don't want it to angle, so in our PCG loop here, I'm going to just make sure that the angle here is always consistent by going from the input into a set attributes node. And what I want to do is specifically on input source 1, I want to go to point rotation, and we're going to make sure it's rotation dot pitch. And that is going to be set to 0, and that's going to go into the target. And you'll see there's our straight room now. Now it no longer rotates. So now if I go ahead and hit play, you can see there's our maze with a guaranteed path solution. If I just walk around and only go into the rainbow rooms, I know I will guarantee a way of getting to the final area. And that doesn't stop me from potentially running into dead ends anyway, because there are still dead ends within every single module, but it definitely makes it potentially a little easier to find the solution. And as you can see, I've already gone the wrong way. Even though I know it is connected and I might be back to where I was, I'm already lost, but that's a maze. Now I know this tutorial was kind of long, but there was a lot to go over in setting this up, but hopefully it has shown you different things about how to potentially use level instances, how to cut them out and use them with partitioning, and hopefully it has been helpful overall. Now, as always, if you'd like to play around with this project file for yourself, it is available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. If you'd like to join our community, the link to the Discord will be down below as always. And if you're looking for more awesome PCG tutorials, check out this one right over here that I really enjoy.